So we're being asked to factor the polynomial. I see that I have three terms, and I see that this is the first time that I am having a leading coefficient to not be 1. So if you ever have a leading coefficient not 1, the very first thing that you need to do is you need to check to see if there's by any chance a GCF in the problem, so we could factor out a GCF and make this problem maybe simpler to solve. So if you recall, the long way to find the GCF, if you cannot find it and see it, is to do the prime factorizations. Because there were three terms, there were three lists, and we prime factorized every single thing in the list. If there is a GCF, then it is a value that they all have in common. So I see that there is a 5 in each list, so there is a 5 in my GCF. I see nothing else in common. The question my students normally have is, do I have to do these lists? Because I could see the GCF in here. If you can visually see the GCF and come up with it in your head, then you don't have to do these lists. This list is to help you identify the GCF if you cannot see it by just looking. So I'm going to factor out a GCF of a 5, and then in parentheses, I need to say what was left over after I took out the GCF. So you're going to divide each of these by the 5. So 5x squared divided by 5 gives me an x squared. I will also notice that that is what is left over from the first list. 15x divided by 5 is a positive 3x. You will also notice that is what is left over from the second list. Positive 10 divided by 5 is a positive 2. I will notice that that is also what was left over in the last list. So you can either think of it as dividing, because that's what factoring out is, it's division, or you can find it by the leftovers over here, which shows you what happened when you divided. So the long way, in case you can't find it, this way. So after we did that, this right here inside the parenthesis is our new polynomial. This is what we're needing to factor. And so the first thing you need to do is you need to look at A. Is A 1? A is 1 in this problem, so if A is 1, then you can go ahead and do the pattern that we recognized in the last video. And remember, to be able to do the pattern, you had to identify A, you had to identify B, and you had to identify C. A is always the number in front of x squared, B is always the number in front of x, C is always the constant. And then you have to do whatever A times C is has to add up to B. So my A times C is 1 times 2. So A times C is a 2. My B was a 3. So I'm looking for the two numbers that multiply to give me 2. So I know 1 times 2 will multiply to give me 2. If I add these together, I do get 3, which is the number that I was looking for. So these are the two values that I need. Now remember, we're doing the pattern that we noticed. The pattern said we don't have to use the area model anymore. So if I'm factoring this, I now have two parentheses. Since the variables are x's, we have x's in the front. That's a positive 1, and that's a positive 2. These two parentheses right here are the factor of that. You cannot forget the GCF because he is also still a part of our problem. So this 5 right here is because we had a GCF. These right here is what your area model factors would have been if you did it in an area model. So your final answer is 5, parenthesis x plus 1, parenthesis x plus 2. And you just factored your new polynomial. So I'm being asked to factor the polynomial, and I see that my A is not 1. If A is not 1, you first need to look for a GCF to see if there's any way to simplify this problem. I'm looking at it. I can think of no number that can divide both 4, 13, and 3, and I do not see any variables that x squared, x, and a no variable have in common, which meant my GCF is just 1. If you went ahead and did the lists, you would have also realized that they had no factors in common, so your GCF is 1, which means this is the number that we are trying to factor. Step number 2 says to look at A. My A is not a 1. If A is not 1, we do not have a pattern for that, so that meant that you had to go back to the area model and you had to solve it the way we did at the very, very beginning, which means you need to find A, find B, and you need to find C, so that you could do your lists of A times C is going to add up to B. So my A of 4 times my C of 3 is 12, and my B is a 13. I need to find all the ways that multiply to give me 12, and one of them is going to give me a 13 when I add them. I know that 1 times 12 gives me the 12. 1 plus 12 gives me 13, which is the number that I needed. So I just found the two values that I need. Now we needed to split this middle part so that we could actually factor it because we have to use the area model. So this 4x squared stayed exactly as it was. You just found that we are going to use a plus 1x and a plus 12x, and then you are keeping this plus 3. This 13 was rewritten as plus 1x plus 12x. So 1x plus 12x is a 13x. We had to put it into 4 terms so that we could then use our area model. So start at the very front. We're going to walk on through. You do it the same way we have in our previous videos. I need a GCF for the top. So 4x squared and 1x have a variable in common. They each have 1x, so my x is going to come out here. X times 4x is going to give me a 4x squared. X times 1 is going to give me a 1x. 1 times 3 will give me the 3. 3 times 4x does give me 12x. I did not have a GCF, so I don't need to write a GCF at the beginning. My sides are my factors, and this is my factored polynomial. So we're being asked to factor the polynomial. My a is not 1. If a is not 1, the very first thing that you need to do is you need to find the GCF. We find the GCF either by looking at here and recognizing patterns that we see or doing our lists. So I'm going to go ahead and do it the list way so you can see it. So remember, 3 terms meant 3 lists, and you had to prime factorize all these. So to find our GCF, we're looking for what the lists all have in common. I see they all have a 2 in common, and I see that they all have an x in common. So that 2 and that x got put down in the GCF, which meant my GCF is a 2x. So I'm going to divide all of these by a 2x because that's what they had in common that I could factor out. You could either observe what's left over in the lists, so negative 7x and positive 2, or you could have divided. 6 divided by 2 was the 3. X to the third divided by the x was x squared. Negative 14 divided by the 2 is negative 7. X squared divided by x was x. 4 divided by 2 is 2. X divided by x, there were no variables. So these came from either dividing by the GCF, factoring it out, or you observed it in the lists. They were the leftovers. So now we have to look at what our new polynomial is, and we have to identify a. Is a 1? No, it's not. So since a is not 1, that meant that we had to go back to the long method of using the area model. We have no trick pattern to do. So that meant we had to identify a, identify b, and identify c. So we can come up with our a times c adds up to b list. So my a3 times my c2 gives me 6. My sum of b is negative 7. So I need to come up with all the ways that multiply to give me 6. I know 1 times 6 gives me 6, but if I add these two numbers together, I get 7, not the number I wanted. But what about negative 1 and a negative 6? If I multiply these two together, I do get 6. If I add these two together, I do get a negative 7, which is the number that I needed. So I just found the two values that I needed. Now coming up here, the reason why we had to do this, we need the area model. The GCF is still a part of the answer. We are trying to split this middle term like we did in other videos, so we would end up having 4 terms in our polynomial. So instead of a negative 7x, I'm doing a negative 1x and a negative 6x, and that plus 2 stays the same. If you are currently lost, you might want to go back and watch previous videos on how we learn to split a 3-term into a 4-term polynomial. So this is what we are doing the area model on because he is our polynomial. Why do we have to do the area model? We have to do it because a was not 1. The little trick of avoiding the area model is only when a was actually 1. So I filled in my area model. The very top, GCF. They do not have a number in common, but they do have a variable in common. They have an x. If he is x, this has to be 3x because x times 3x would give me 3x squared. X times a negative 1 would give me negative 1x. Negative 1 times, this needs to be a negative 2. I'm going to multiply these two together to get a positive 2. Negative 2 times 3x does give me a negative 6x. So my area model panned out. So first, cannot forget your GCF. Your GCF needs to still be a part of your answer. Now you need the two parentheses that come over from your area model. Side 1 says x minus 2. Side 2 says 3x minus 1. So these parentheses came from the area model factors. So this right here is your final answer, and you're done. So we're being asked to factor the polynomial. A is not 1. If A is not 1, you need to start off by looking for a GCF. Can we by any chance make this problem easier? You can either observe a common number that they can all be divided by and a common variable, or you will need to do the lists. I'm going to go ahead and do the lists so you can see it. So remember, 3 terms meant 3 lists. Our GCF is what they have in common. So I see that there is 1, 2 in each list, so that 2 comes down here. I see another 2 in each list, so that 2 is going to come down here. There's another 2 in each list, so I'm going to bring that 2 down here. And they have nothing else in common. 2 times 2 is 4. 4 times 2 more is 8. So my GCF is an 8, which means I need to divide all of these by 8. Or you can look at your leftover for your lists. So I have x squared minus 7x plus 6. 8x squared divided by 8 is an x squared, or I saw x squared was left. Negative 56x divided by 8 is a negative 7x, or I could see that was left over in list 2. 48 divided by 8 is 6, or I could see that was what was left over in list 3. So this is our new polynomial that we are trying to factor. Now looking at it, we have to observe what A is, because that tells us either to use the area model or our trig method. A is 1. So since A is 1, that means we can use the pattern that we observed. To use the pattern, we have to identify A, I have to identify B, and we have to identify C. So I need to do whatever A times C is. A times C, 1 times 6 is 6. So something has to multiply together to give me 6, and has to add together to give me negative 7. I know 1 times 6 will multiply to get 6. But if I add these together, I get 7. It's not what I wanted. I know a negative 1 times a negative 6 will multiply to give me a positive 6. And if I add these together, I get negative 7, which is the number that we wanted. So these are the two numbers we're going to use. Now we said we were going to use the pattern. If we're using the pattern, that means that we can automatically write down what our factors are. Since the x's are the variables, the x's go up front. That was a minus 1, so there's my minus 1. It's a minus 6, there's my minus 6. You cannot forget about your GCF. The GCF stays there as well. So this 8 came from the GCF. These two came from the area model factors if you did the area model, but we went ahead and we recognized the pattern and we skipped a few extra steps. This right here is your final answer, and you're done. So we're being asked to factor the polynomial, and I have this polynomial, and the A is not 1. And so the very first thing we're supposed to do is we're supposed to look for a GCF, but I'm going to tell you right off the bat, your first number is never allowed to be negative. So we have to factor out a negative 1 first. So let's go ahead and factor out a negative 1 to begin with and see what we have left. If I'm factoring out a negative 1, that means I'm dividing everybody in here by a negative 1. So I have 4x squared plus 8x minus 5, because negative 4 divided by negative 1 is 4. Negative 8 divided by negative 1 is an 8. 5 divided by negative 1 is a negative 5. So this is the polynomial that we're doing. Now why did we do this without checking? Because your front number is never allowed to be negative. So we had to factor a negative out first. Now we're going to go through and we're going to see, is there any number that can divide both 4, 8, and negative 5? No, no single number divides all three of those. And they do not all share a common variable, which meant that our only GCF is going to be a negative 1. There is no other GCF. So now we're going to move on to step 2, which says, hey, check out A. A is at 1. A is not 1. So if A is not 1, that means that we have to do the long area model method to factor it. So I need to find A, which you said was 4, B, which we said was 8, and C, which we said was negative 5. We have to do the A times C to figure out who adds up to B. So A, 4, times C, negative 5, means I'm looking for a negative 20. B is 8. So I need all the ways that multiply to give me negative 20. I have a negative 1 times 20, or the negative was on the 20. Both of these would give me negative 20. If I add negative 1 and 20, I get a 19. If I add 1 to a negative 20, I end up getting a negative 19. So neither of those give me the 8. So the ones didn't work. So try 2's. So either a negative 2 with a positive 10 or 2 with a negative 10. Both of these would multiply together to give me a negative 20. Negative 2 and 10 would give me my 8. 2 with a negative 10 would give me my negative 8. I was looking for a positive 8. I found it right here, which meant these are the two numbers that I'm using. So come over here. We said that we had to use the area model, which meant that we are trying to split this middle part right here into two numbers. Can't forget your GCF. The 4x squared stay as it was. We are splitting the 8x into a minus 2x and a plus 10x, and the minus 5 stays the same. We were just splitting this middle term into two so we could have 4 terms, which would allow us to use the area model on this polynomial. So here's our area model, and now we got to find the GCF. Looking at the top, 4 and 2 both have a common value of 2, GCF, common factor of 2, and they both have a common factor of x, so 2x is here. Now we're just going to go around, we're going to multiply the rest. 2x times another 2x would give me 4x squared. 2x times a negative 1 would give me negative 2x. Negative 1 times 5 would give me the negative 5. 5 times 2x gives me the 10x. So I went ahead and I factored the sides. Do not forget about your GCF. Your GCF is always the first thing that gets listed in your answer. Your area model gave you two sides, which are the two parentheses. This is 2x plus 5, and this is 2x minus 1. So these two parentheses came from the area model factors. So this right here is your final answer, and you're done.